All right, so now we know about factoring. We're going to start working on solving some equations with this. What we're working with now is going to be quadratic equations. So our objective is going to be really finding zeros of quadratic equations and solving them using principles like the zero product principle. We're taking out square roots. We have to cheat around that, or not square roots. Completing the square we're taking out. We are keeping square roots. Quadratic formula. Solve equations that are reducible to quadratics. So we've kind of seen that before when we were doing factoring, and solve applied problems using quadratics. So we have, I think, one applied problem. Sorry, it's not letting me switch pages. There you go. So quadratic equations. So quadratic equations, they're a type of polynomial, but in this case, it's going to be a particular type of polynomial, and it's one that has a degree of 2. So that means that its highest power on x is going to be 2. But it's going to be written in this form. We've always seen this: ax squared plus bx plus c. So equal to 0, because you got set equal to something to be an equation. A, B, and C have to be real numbers, and it's important that A is not 0, because if A is 0, it's not a quadratic equation anymore, because we have to have that x squared. So a quadratic equation written in this form is said to be in standard form. So we have a lot of equations that we'd like to write in standard form. Actually, when we were dealing with linear equations, we had something similar to this. That was also your standard form. All right. So the quadratic function f is a function that can be written in the form fx equals ax squared plus bx plus c. Once again, a cannot be 0. A, b, and c are just real numbers. The zeros of a quadratic function. All right, so we're going to go over this. Zeros of a quadratic function are solutions to this equation. So if we want to find zeros, then we have to set our quadratic function to 0, and then we need to solve that quadratic equation. So like I said, so solutions to the quadratic function are different than solutions to this here. This is the case where y is 0. So we're only looking for a particular set of solutions, not all your solutions. So a quadratic function can have real number or imaginary number zeros. We'll get to imaginary number later. And quadratic equations have real number or imaginary number solutions. The zeros are referred to as roots and x-intercepts. So the principle of zero products. So this is a pretty easy one. Basically, all this is saying is that if we have two numbers multiplied together and they result in a 0, so their product is 0, then at least one of them or both of them have to be 0. Also, if one of them is 0 and we multiply them, that means the product has to be 0. So what this is really saying is I have two things multiplied together and they equal 0. One of those two things itself has to equal 0. Okay, so if we're given the equation x minus 2, x plus 5 equals 0, we know that the product, that the we know from the zero product rule that either this here has to equal 0 or this here has to equal 0. So we look at both of those binomials. So what we do is we set each one individually to 0, and then we just solve for x. And these ones are easy ones. Some are a little more complicated. So therefore, if you solve This was typos that came out of the book when I copied it. Therefore, if you solve each of the above equations, the solution is going to be, we have two choices. If x is -2, +2, then if we plug it in here, this product will be 0. This is going to be 0. If x is -5, if we put in -5 ends up in here, then we add this, we get 0. If we multiply, it doesn't matter what's over here. This is going to be 0. So let me do the first one here. So if my x's were 2, this is just what we're seeing. So this is how we know it's a solution. We get 7 times 0 equals 0. Yep, that's why it's a solution. If x is 5 instead, oops, sorry, -5. We'll have a -7 times 0 equals 0. Once again, 0 equals 0. So what we can do is we can use that, everything we learned about factoring, to get something, oops, that looks like it's in this form. So we're going to have 2x² minus x equals 3. So something to point out here is that this here I can't factor. What I have to do is I have to move everything to one side and have it set equal to 0. So we're going to do some little solving techniques to set equal to 0, which is going to be pretty easy in this case. If I just subtract 3 from both sides, then I have 2x² minus x minus 3 equals 0. So now we just have to factor. So this is going to be an AC method. So we have 2 times -3 is going to give me -6. So I need factors of -6. And what we want to see is we want to find the ones that are going to sum to a -1. So we're going to look at the sum of those factors. So we have -1 and 6. If we add those together, it's 5. If I have 1, -6, if I add those together, I get -5. If I have 2 and -3, there's also factors. 2 plus -3 is -1. So like we were doing before, we're going to stop there because those are my two factors. So what that's telling me is that 2x² minus x minus 3, that minus x can be broken up into a 2x and a 3x. Like I said, this is kind of like just a little bit of review here. And we know it's all set equal to 0. So here I can factor out a 2x. I'm going to be leaving behind a x plus 1. Here I can factor out a -3 and leave me with x plus 1. So if I factor out x plus 1, then I'm left with 2x minus 3. And we know that all equals 0. So now we got our two binomials. Either x plus 1 equals 0 or 2x minus 3 equals 0 to cause this to all equal 0. So like I said, all we're doing is just solving for x. So here I just subtract 1 from both sides. X can be -1. Here's a little bit more work. I have to add 3 first. So 2x equals 3. Then if I divide by 2, I get 3 over 2. So my two solutions are going to be x equals -1 and x equals 3 over 2. And you can plug those in and check again. So what we do is we always take our equation and we try to rewrite it so it's set equal to 0. Because once I do that, as you see, I have a quadratic here and we know how to factor a quadratic. So then I just go through my factoring techniques to factor that quadratic. And it's going to give me, once again, my two solutions. We also have a principle of square roots, which is really just telling me if I have x squared equals k, then what I'd have to do is that when you take a square root, you're going to have a positive root and a negative root. So this goes back to the idea, like, let's say you had, sorry, I don't know why I put the cube there. You have 9. And you need a number that when it's squared is going to give you 9. And you really have two choices here. Either it's going to be -3 will give you a positive 9, or +3 will give you a positive 9. So that's why we end up with a positive root and a negative root. Let me fix this up over here. Is because I know there's two numbers that can be squared that's going to give me a positive result. So in this, like I said, in the case of 9, I know it's going to be, I can square a -3 and get a positive 9. I can square a positive 3 and get a positive 9. So by our principle of the square roots, if I have x squared equals k, then x equals square root of k, or x equals the negative square root of k. So we're going to solve this one using factoring. What I want to do is that you notice that I do not have this b. B is missing. So when you have that case, that is when you're going to use that square root principle. So what I'm going to do is solve for just the x squared. So if I do that, I'll have to add that 10 to both sides. So then I have 2x squared equals 10. Then I have to divide both sides by 2. And I get x squared is equal to 5. So if I just want x, my two solutions are either it has to be the negative square root of 5, or it has to be the positive square root of 5. And those would be your two solutions to that equation. So I had brought this up once before, I believe. Remember that the square root of a negative number doesn't exist in the real numbers. So we're saying as long as I'm in the real numbers, if I try to do the square root of -9, it doesn't exist because I need two numbers that are the same that I can multiply, because right, we're squaring it. And we already saw that the squaring is just going to either result in a positive 9 or a positive 9. I can't make it be a -9. As long as we stay in the real numbers. So this is just sort of a guideline to help you solve polynomials. So first thing we want to do is rearrange the polynomial or quadratic so that it's equal to 0. So that's what we did with our first example. Factor the polynomial, set each factor equal to 0 and solve. If you have a case where you have an x squared term, but you don't have that x term, then what we're going to do instead is we're going to set that x2 term equal to the constant. So we're going to solve for that x squared. And then we're going to solve with the square roots. That brings us here. So if you could pause for a moment, we have, okay. 1, 2, 3, 4, 5, 6. Yeah, it was just 6. We have 6 of these to work on, so it's just using those factoring techniques, or in some cases, the principles of square roots, and just to solve each one of these quadratic equations. So pause for a moment, work on those, and then come back. All right, so working on this one. There we go. So this one, we don't have to try to solve it so it is equal to 0. It already is. We just have to factor. So this one, we just need to find factors of 32. And then we need one to find, we're going to do that sum of factors. And we want the ones that are going to sum to 12. So if you think about that for a moment, that one should actually come pretty quickly. Like I'm trying to find it here quick. So a very obvious one would be, because everything is going to be positive, because everything's positive. 4 and 8. If you multiply those together, you get 32, but if you add those together, you're going to get 12. So in this case, like I said, because we're not using AC method, this is just telling me what I'm factoring it into. This is just going to be x plus 4, x minus 12, all that's going to equal to 0. So we know we have the choice that x plus 4 equals 0, or x plus 12 equals 0. Oh, sorry, the Zoom is just not great today. And then if we solve for x, we get x is equal to -4, or x is equal to -12. So your solutions would be x such that x is either -12 or -4. Okay, so solving using factoring again. This is a case where we do have to solve it so it is set equal to 0. So what we need to do is just subtract 9x. So we can get rid of it here, and then we're going to have x squared minus 9x plus 14, and that will be equal to 0. So once again, we just need factors of 9. And then we need to find the sum of the factors that are going to give us a -9. Or sorry, we need to stack factors of 14, not 9. And we need the ones that will sum to -9. Apologize, my tools aren't working super great on here today. So I think of 2 easy choices that should give us a 9. 7 times 2. We add those together. Well, that's a positive 9. Well, I could do a -7 times -2. -7 plus -2 would be -9. So I know my factors would be x minus 7, x minus 2. So that means we have the choice that x minus 7 equals 0, or x minus 2 equals 0. If we solve them, we get 2 solutions. So my solutions are x such that x could be 2 or 7. So this one's going to be another one of those AC methods. First thing we want to do is subtract 3 from both sides so that we have, I'm going to write it over here while I break it up, 2x squared minus 5x minus 3 equals 0. So that is the rewritten version of this. So I need factors of, because we have to use the AC method. It's going to be factors of 6 again, negative 6. And then the sum of those factors will have to be that negative 5 in the center again. Or not again, last time was something different. So an obvious choice here would be a negative 1 times 6, because if we add those together, we're almost there. Oh, it's a positive. So let's try it this way. Well, it's a positive 1 and a negative 6. Now we get negative 5. So like I said, AC method, so it tells me how I break up the 5. Like I just lost what I said it was. So we said we can break this negative 5x into x, and it's negative 6x. Now we do our grouping. So if I group these two, I can factor out x, which is going to leave me with 2 plus 1, or sorry, 2x plus 1. These ones I can factor out a negative 3, which would leave me with a positive 2x plus 1. If I factor out my 2x plus 1, then I'm just left with x minus 3. So like I said, we're just going through solving this. I've got it factored, so I have two choices here. Two x plus 1 equals 0, or x minus 3 equals 0. So we'll solve this one first because that's the fast one. All right, and so x could be 3 would be one of my solutions. Here, if we're solving for x, we're going to get x is negative 1/2. So I have two solutions. Again, my solutions is either x is negative 1/2 or x is 3. All right, so this is just a little different. So in this case, it looks like we have a whole polynomial over here, but it's still not set equal to 0. So you might be tempted to start factoring this, but you still have to move this over here if you actually want to solve the equation. Because we need to use that 0 property because once we have the factors, we have to have them equal to 0, so then I can use the 0 property to solve them. So we're going to add 9 to both sides. So we get 6x squared plus x plus 16. This is going to be fun to factor. So we need factors of our AC, so that'd be the 6 times 16. Let me find that again, 6 times 16, which will be 96. And we want a sum of those factors. And we want the sum of those factors to be that positive 1 here. Sorry, my 96 looks like not what it was supposed to be. 96. I was looking at going, that doesn't seem right. Okay. So what we need to do is we just need to find the two factors that are going to give me that positive 1, if they happen to actually exist. All right, so there, I paused that so I can write those all down for you. So this would be your list of factors for 96. What we'd have is, if we add those together, well, they sum to 97, or these two, 2 and 48, sum to 50, 3 and 32, sum to 35, 4 and 24, sums to 28, 6 and 16, sums to 24, 12 and 8, sums to 20. So we're seeing in no way are we going to get that positive one. So this one does not factor, at least the way we understand it. And actually, I'm going to show you the graph of this one. So this doesn't factor the way that we understand how to factor. You still have two other options of what we're going to be, of things we're going to look at. One is maybe it doesn't have a solution that's a real number solution. The other is that it may have, what we said, it's like to be a prime meant we'd had roots, or our factors anyways, contained, you couldn't have rational numbers. So this may have be one that has solutions that are not rational numbers. So like I said, it doesn't factor. So either no solution, the real numbers, or no rational number solutions. Meaning that if we were to look at it and actually find solutions that were real numbers, they probably have square roots in them. Like I said, I'm going to give you a graph of this one here in a moment. So if you did the graph of 6 anyways, 6x squared plus x plus 16, so I set it to equal to y right now. What you're seeing here is that for it to have zeros, for this to be true, that would mean that we'd have to be able to have y's that are 0. So it would have to cross like this. So we would have to have x-intercepts. We have no x-intercepts. So we have no x-intercepts, which means that if I set this equal to 0, there's no solutions that I'm going to get. So we have no solution in the real numbers. Okay. Like I said, it could have been there were solutions, we just can't find them with factoring. It also could just simply be there's no solutions in the real numbers. Okay, so this is one that we're, as we see, we do not have an x term, we just have an x squared term. So we're going to use that property of square roots. So if I divide both sides by 3, I get x squared is equal to 12. So according to the square root property, I have two choices. Either x is the negative square root of 12, or x is the positive square root of not 12, I'm sorry, 4. So if we divide by 3, we should be left with 4. X is the negative square root of 4 or the positive square root of 4. Or we'd say it's negative 2 or x is a positive 2. Okay, so this one, as we work on it, you're going to kind of see what's going on. So you, as you're seeing this, polynomial, you might be tempted to do this first. Well, let's get rid of the 8 first. Go, okay, well, I need to move this 8 over here. So we're going to subtract 8 from both sides. Then you go, well, I still got that x. I got to subtract that from both sides. And all of a sudden you're left with this, x squared minus 16, my x term has disappeared. So like I said, if you go back to that principle of square roots, or go back to what we said about square roots, is that we don't have that middle term. So what I'm going to do is just rewrite this. So I'm just going to add the 16 back over here. So you may have caught that early and not done all this work. But like I said, if that happens and you find your middle term disappears, then you just know that, oh, well, I have an x squared in this number. I have to use the principle of square roots. So we have our two choices. X is either going to be negative square root of 16, which is then -4, or X is going to be positive square root of 16 or +4. So my solutions are X such that X is equal to a positive or -4. So the positive or the negative version.